Until recently, AI in software development has functioned primarily as a high-speed autocomplete. These tools can suggest a logic block, but a human engineer still has to manually organize and connect every individual component, piece by piece. At Google I/O, that dynamic changed with the release of Antigravity 2.0. The focus has moved away from tools that help us write code and towards autonomous agents capable of taking independent action. This change lowers the technical floor for entry. Because the agent handles the implementation, anyone with a high-level goal, from a non-technical designer to a busy CEO, can effectively become a software builder. When the machine manages the execution, the human role in software creation changes. We move away from the manual labor of writing syntax and into the role of high-level orchestration. To prove this agent-first architecture was viable, Google's engineers designed a specific stress test. They tasked the system with building a functional operating system entirely from scratch. Building an operating system is a notoriously brutal undertaking. It requires the development of a core kernel, a process scheduler, memory management, and a robust file system, a project that typically takes human teams many months to complete. The engineers provided the objective and stepped back. The AI was left to break down the challenge into a plan, execute the code, and then independently generate and run its own tests to verify the work. This project requires deep, interconnected architectural logic. It forces the system to manage complex dependencies across the entire stack, rather than simply generating isolated lines of syntax. This level of coordination was not possible on the previous Gemini 3.1 Pro model. It required the new Gemini 3.5 Flash engine, co-optimized to run 12 times faster within the anti-gravity harness. The agent harness enables this speed. Instead of linear processing, it breaks macro goals into parallel tasks. Over 12 hours, 93 subagents worked simultaneously, making 15,000 model requests and processing 2.6 billion tokens to build the OS. Perhaps most significantly, the performance of the 3.5 Flash model kept costs remarkably low. The entire engineering effort for a functional OS consumed less than $1,000 in API credits. The speed and efficiency of this swarm suggests that autonomous subagents can now outpace the traditional timelines and costs associated with human engineering teams. The system eventually delivered a working product. To verify it, the team opened a terminal in the new OS and successfully ran the SL locomotive utility, complete with an animated train. However, the team hit a roadblock when they tried to play the game Doom. The OS was functional, but it was currently missing the specific video and keyboard drivers required to run the game. The human engineer didn't open a code editor to troubleshoot. Instead, they dropped a simple prompt into the Antigravity UI, directing the agents to identify the missing drivers and fix the issue. While the agents work, the Antigravity 2.0 interface serves as a high-level command center. It can display research tables, complex data plots, and even custom infographics generated by Nano Banana Pro to show the progress of the build. In this environment, the human experience is decoupled from the code itself. The user manages the high-level objectives, while the AI independently audits the system and patches errors in the background. The diagnostic worked. The agents identified the missing components and wrote over 100 lines of custom driver code. Moments later, Doom successfully booted and ran on the live, agent-built operating system. This capability isn't limited to experimental operating systems. Google is already tasking agents with building multi-user collaboration tools, real-time messaging apps, and photo editing suites. For these common consumer applications, engineering efforts that once took several days are being compressed into a matter of minutes. This stress test demonstrates that the traditional bottlenecks of complex software engineering have been effectively trivialized by AI teamwork. Antigravity 2.0 is globally available starting today. It integrates natively with the tools developers already use, including Firebase and the broader Android ecosystem. The nature of software development has shifted. We are moving away from the manual entry of syntax toward the high-level orchestration of active agents. As the technical barrier to entry evaporates, the traditional monopoly of the coder is coming to an end. The future of software no longer belongs to those who know how to write the code. It belongs to those who know how to direct the intelligence.